So what we are doing today are finding areas. This is a little bit different than what we did before, but not drastically. First difference is up till this point, you've been finding the area between a graph and what? The x-axis. I'm going to add a second graph in. So instead of one of the graphs being the x-axis, there's going to be an actual other graph, and you're going to find the area between them. Is this making sense? Okay. Technically, there's always been two graphs. It's just one of them was zero. Right. Second difference is we're just finding areas, period. Can an area be negative? No. So there is no more above and below sea level. This is just what's the area of the shape that we got. Do you get what I'm saying? Yeah. So really the only two differences, okay? Also, sometimes the graph can be sideways. Your graph is right side up. It's going to be what you've done from the beginning, okay? You're going to do the top curve minus the bottom curve. It's just one of your curves has been zero, all right? Integral from, the beginning to the end. If it's sideways, instead, it's going to be right minus left. And I know the question you're all thinking right now is, hey, Ms. Cole, how do you tell whether it's sideways? I unfortunately do not have a good answer for you. You're going to need to practice enough of them until you can start to tell what sideways looks like, okay? But there are clues that can help indicate that it is sideways. And when it's sideways, instead of dx, it's going to be dy. Just be really careful with that. You can't mix and match x's and y's. So if you have a statement inside of your integral that has x's in it and then a dy at the end, you've done goofed. You can't mix and match them together, okay? That's all I have to say about that. We're just going to try a few problems. Now you need to know how to graph. So welcome back to Algebra 2. What is this graph going to look like? Quadratic moved up 2. All right, so you're going to start at 0, 2. I'm going to plug in some points to either side. So if you plug in 1 to this, you're going to get 3, and then you get the buy one, get one point. And if you plug in 2, you're going to get 6, and then, symmetry. You like what? Yeah. Buy one, get one points. I like that too. Symmetry. Next graph, y equals negative x. That's going to be a line. It's going to start at the origin because I don't have like plus anything here. It didn't move up or down. And then what's your slope? -1, down 1 over 1. So if you can count to 1, you can do it. And then x equals 0, that's vertical line here at 0, that's this. And x equals 1, that's a vertical line at 1. So what we are going to find, and I know you don't care, but this does kind of geek me out. We're going to find the area of that thing. That's cool. You can find the area of weird shapes now. They don't have to be rectangles or trapezoids or triangles. You can find the area of anything that you can write an equation for, which is neat. That's neat. Get on board because that's cool. It's kind of cool. All right, so this one is right side up. Do you remember the Riemann sums with the rectangles, all the things? You can think of it this way. Do you see how all your slices would be vertical? Like you'd have all this infinite number of rectangles and they're all vertical, right? So it's going to be integral from where to where do you think? Because I don't want to tell you, if you just let your instinct kick in, 0 to 1, and it's the top graph minus the bottom graph, upper minus lower. That should make sense. If you take up here minus down here, that gives you what's in the middle, right? So which one is the upper one? Yeah, the quadratic one, so x squared plus 2, minus the lower one, which is what? Yeah, negative x. And at the end, dx. Really important. Now you're going to do fundamental theorem of calculus. You're going to do an antiderivative for boundary minus lower boundary. So what's your antiderivative of x squared? 1/3 x cubed, good. Plus antiderivative of just 2x. Now, do you see how these negatives would cancel? Yes, okay, so plus, and then what's your antiderivative of just x? Have x squared. Good job. Such that 0 to 1. Now it's upper minus lower, but I'm not going to bother plugging in 0. Why not? They would just all be zero. It's there, we're just not going to write it, okay? So let's plug in 1. That's going to give us 1/3 plus 2 plus a half. If it seems reasonable, I'm going to keep going, because if this was multiple choice, your choices wouldn't look like that, and you would have to get a common. Good. So between 2 and 3, your common denominator is 6. So this would be 2/6 plus, good, 12/6 plus 3/6. And all together, that would give you 17/6, which is the area of that, which is cool. It's neat, guys. You can disagree, but I'm right. It is right. I mean, it is cool. All right, let's try another one. Find the area bounded by these two graphs. All right. This is again going to be a quadratic, but it is flipped, concave down, and moved up 2. So we're going to start at 0, 2, and we're going to expect it to look upside down. So if you plug in 1, what do you get? 1. Good job. If you plug in 2, what do you get? Yeah, -2. And then the other one is just f of x equals x. Again, it's going to start at the origin. And what's your slope? 1. So just up 1 over 1. So again, if you can count to 1, you're good. So we're going to find the area of this. That's so cool. We're going to find the area of this shape. I don't know. What would you even call that shape? So it is right side up. And again, you're going to just learn right side up or sideways from doing a lot of problems. But do you see how if I slice this up, all my rectangles would be right side up, like vertical? This graph is above that graph. You have to just be able to see it. It's not something I can teach, all right? So your integral is going to be from where to where. Sometimes I tell students to highlight the intersection points, because it's going to be from here, -2 to 1. Good job. Do you see that? -2 to 1?
No, yeah.
No, I was talking to that one. Are you good? Okay. Oh, okay. All right. Well, I was just making sure. All right. And then it's upper graph minus lower graph. So that's going to be this one minus what? Just x. And then dx. Antiderivative. Going to be really similar to the one we just did. I take it easy on you guys. I should make it harder. But anyway, it's going to be 2x minus 1/3 x cubed minus 1/2 x squared. Unfortunately, we're going to have to actually do both boundaries. Womp womp. Neither one of them 0. And be careful, because sometimes, even though one of the boundaries is 0, when you plug it in, you don't get 0. And the one I always tell everybody to think of, sine of 0 is 0, but cosine of 0 is 1. So be careful with cosine, because sometimes people will just, if they see one of them 0, they'll just throw it out. And sometimes it's not 0. So just be careful, is all I'm saying. All right, upper minus lower, just go ahead and set it up blank. We're going to plug in 1 to everything. So that would give us 2 minus 1/3 minus 1/2. And then if you plug in -2, that's going to give you -4. All right, now let's fight our way through this one. -2 cubed, -8. Negatives cancel, so it'll be plus 8/3. And then the last one, -2 squared, 4, half of that, 2. So -2. We're going to keep going. This one's not unreasonable. We can do it. Now, I'll tell you how I think through this. And if you think differently, that's totally cool. I just copy the first stuff, like, hey, looks like you just rewrote it, and then distribute the negative. Because often what happens is things will either combine nicely or cancel out. There's a lot of symmetry in mathematics, so I usually just do that. So let's group together all the whole numbers. If you group together all the whole numbers, what are you going to get? 8, good. And then let's group together the thirds. And this is what I was saying, because it's going to work out nicely. -1/3 and -8/3. That's negative 9/3, which is 3. And then what's still in there that I didn't, yeah, minus a half. So what is that going to shake out to? 8 minus 3, 5 minus a half is 4.5, or 9/2 if you're a fraction purist. We'll do one more and then I'll give you a halfway break. All right, find the area bounded by that thing, the x-axis, and -1 and 2. All right, so let's go ahead and see if we can get some points out of this. This is going to be a little bit more of a battle here. But it is cubic, so it should be a wiggle. It should go like this. Do you get what I'm saying? So we need enough points till it looks like that. What would be the easiest value to plug in? I would say 0 would give you 3, but next on the list would be 1. I'm just going to make a table off to the side. You plug in 1. Let's see. 1 minus 3 be -2. Minus 1 would be -3 plus 3 is 0. What else do we want to do? I do want to do -1 and 2. So I agree with both of you that said that. Let's do -1. That would make this here. I'll just write it out. -1 minus 3. Ooh, what would this be? Plus 1. Good job. Plus 3. So 0. I told you it was going to keep turning around. All right, if you plug in 2 cubed, 8. 2 squared is 4 times 3, 12 minus 2 plus 3. Did I do that right? So what is that coming out to? -3? Did I do that right? Yes, okay. So -3. And I needed to turn around one more time. So look, it's going to go up like this, go down. It needs to come back. Can I just go ahead and tell you the point's going to be here? Is it like, you guys got it? Okay. Not trying to torture you. So something like that. Now also the x-axis, so if you want to like highlight that, you can, but it's sort of just there. And then x equals -1. It means we're going to start at -1, and then we're going to go to 2. So the area that we're finding, and again, there aren't going to be any negative areas. We just want the total area of this space. Kind of think of it like you're finding the area of a room or something. I just want the total area that is. So it's going to be integral from where to where? -1 to 2. Now it's going to be this equation, but what do I need to put around it to ensure that all this gets counted as positive? Absolute value, good job, of all of that stuff. Dx. Do you see how if there were rectangles in here, they would all be right side up? Oh, go ahead.
So why wouldn't it be the full thing? Like the full.
It says so in the problem. We're starting at -1, which is right here. Or you can draw a vertical line at -1 and then a vertical line at 2. Basically, I'm sorry, I don't have a better answer than the problem says. So it says to start at -1 and end at 2. All right, I'm going to share my screen. Can you guys all watch? When I'm typing, it's your job to make sure I don't type it wrong. Because otherwise, it will count the part below the x-axis as negative. And we just want a total area of the space. Think of it like you're trying to find the area of a room. So we need it for it to count all as positive. Or, like, it's called total distance when we have velocity. You could think of it as total area. Does that help? 5.75. You should never get a negative answer for these. An area is not negative. All right, so the next one, find the area bounded by these two graphs. This is a big hint that this one's going to be sideways. What's different about this equation? Do you see how it's x equals instead of y equals? So it's going to be a parabola, but it's going to be on its side. Okay, do you get what I'm saying? So what we're going to do is we're going to come over here and we're going to make a table. Instead of plugging in for x and getting y, we're going to plug in for y and get x. I know you're not using it, but can you close your code? All right, so I'm going to plug in 0 for y. What would that give us for x? Good. Now, when you plot it, it is still the 0.30, so don't mix your point up. What else do you want to plug in for y? 1 is a good choice. If you plug in 1, you will get 2. Now, it's still the 0.21. Good. All right, what else? -1. If you plug in -1, you will also get 2. I'd like to go a little bit further. What else can we plug in for y? We did 0, 1, and -1. 2 or -2. Can I go ahead and write it like this? Is that okay with everybody? Okay. So if you plug in 2 or -2, it won't matter. That's going to make this part 4. So what do you get for x? Good. So you get -1, 2, and -1, -2. I always have to turn my paper to graph this. I will put it back, but it's a parabola on its side. You should go, hey, wait, hold on a second. What's sort of the matter with that? It's not a function. We don't care though. It's fine. We're just finding the area of a shape. We are finding the area enclosed by graphs. We don't need for them to be functions, so it really doesn't matter. It's like the first time in your life someone's ever said that to you. It just doesn't matter. We don't care. All right. Now this one, y equals x minus 1. So we're going to start at -1. So right there. And your slope is 1. So up 1 over 1. It's going to look like this. So this is the shape that we're finding the area of. Now this one is sideways. Again, I don't have a better explanation than you kind of just have to look at it and see it. But do you see how there's not a clear-cut upper and lower graph? It almost kind of splits right here. Do you see what I'm saying? So your rectangles for your Riemann sum are going to be sideways. Do you see that? Or turn your paper. Does that help? I mean, you have to be able to see it. So this is the right graph and this is the left graph. If putting in your R and your L help you. Now, as soon as you realize it's sideways, the second you realize that, you stop what you're doing and you rearrange both the equations so they're backwards. This one already is, and I don't know why, but I have learned over the years that if I circle this part, it helps everybody. I don't know why, and that's such a silly little thing, but it helps, so I'm going to keep doing it. Now this one you have to rearrange so it is also x equals. As soon as you realize the whole thing is sideways, you have to sideways everything. Make it all sideways. So what would you do to this equation? Yeah, move the -1 over, so it'd be y plus 1. So you get x equals y plus 1. And again, I don't know why, but circling that ends up helping everybody, so I'm going to keep doing it. Now we're ready to set up the problem. Integral from where to where? They have to be y values. It's going to be a dy problem. So you have to look from here to here. Do you see how all the rectangles are sideways? So if you want to highlight your intersection points, you can do that. Where are we starting? Y value. -2, good, up to 1. You have to look at your y values. And then it's right minus left. So which is the one on the right? Yeah, the parabola one, the one with the squared. So 3 minus y squared minus which one? The y. And that's why circling it helps. And at the end, put dy. So watch me point to this. These boundaries are y values. Everything in here is y. And then at the end, it says dy. Do you see how it's uniform and consistent? For the sake of time, because we did a couple of antiderivatives already, and you're going to do it in your classwork, I'm going to just go ahead and tell you that the answer is 4.5, but that should make sense why. It's the exact same problem as this one, except what? It's on its side. Okay, but you're just finding an area. So it doesn't matter where the area is, you're just finding that amount. Okay, try one more. Oh. Okay, so do you see how this is x equals? It's gonna be sideways. This is gonna be a regular old parabola just on its side. So if you want to turn your graph and then just do a regular old parabola, you know, I feel like that's the easiest way to do this. It'll start at 0, 0. You have 1, 1. Where's the next point for a regular parabola? Yeah, 2, 4. You're ahead of us. Brainiac over here is ahead of us. And then 3, 9, and then 4, 16. It's just when you flip the paper back, it's actually 16, 4. I just feel like it's easier to graph this way. And I'm always going to show you the way I think is easiest. But that's the way it should look. So the points are actually 4, 2, and 9, 3, and 16, 4. But it didn't get transformed at all, so I didn't bother making a table. It's just a regular old parabola, just sideways. So it's not a function, but we kind of don't care. All right, the next one, x equals 3y plus 4. It's going to be linear. I'm going to make a table, and we're going to come up with, you know, a few points. But once you get a slope, like let your slope instinct kick in and just keep going because it's going to be linear. We're going to plug in for y and get x. What do you want to plug in for y? 0 and 1 are the easiest numbers to plug in. If you plug in 0 for y, you get 4. If you plug in 1 for y, 7. Now that's still the point 4, 0, which is right here. And this is still the point 7, 1. So what is your slope? You're going up 1 over, just keep going up 1 over 3, up 1 over 3, and connect them. You only need 2 points to make a line. So we're going to find the area of that thing, which is cool. That's so cool. It's neat, guys. This one's a little harder to see why it's sideways, but you don't have a clear-cut upper minus lower graph. You watch, I'll show you. It would kind of split right here. Do you see what I'm saying? Like you don't have this one's not above that one all the time, okay? So it is going to be sideways. Your rectangles are going to go this way. Your infinite number of rectangles. So this is your right graph. This is your left graph if you want to put your R and your L. And we're ready to set up our integral. So they need to be y values. Your boundaries need to be y values. So where are we starting? -1, good job. And then this is your other intersection, 4. So which one is your right graph? It's going to be right minus left. The linear one, yep, good. 3y plus 4 minus y squared. And then at the end, dy. So your boundaries are y values. These all say y, and then you have a dy at the end. So we're going to actually work this one out. Antiderivative of 3y. Yep, there we go. Plus antiderivative of 4. Good. The common mistake is people put 4x. 100% understand why that happens? 100% understand why that happens? But if you're looking over your work later, you should see a mixture of x's and y's and go, oh, I need to fix that. All right, minus 1/3 y cubed. Perfect. Such that -1 to 4. We're going to do upper minus lower, and I'll see how messy this is. If it's not too bad, we'll keep going. If it's an absolute disaster, then we'll stop. So upper boundary, if you plug in 4 squared, 16. I would divide that by 2. 16 divided by 2, 8 times 3, 24. Okay, this isn't so bad so far. Plus 16 minus, oh, this is where it's going to not be good. All right, 4 cubed. 64 thirds, we're probably going to stop. I thought it was going to be all right, but I don't want to deal with negative 64 thirds. All right, if you plug in -1, that's going to make this 3/2 minus 4 plus 1/3. Yeah, I'm going to just go ahead and, well, it's a short answer question.